Hey everybody! Today we're going to be working on simplifying rational expressions. We've done a little bit of this in the past, but we're just going to take it one step further. Make sure that you are pausing and taking the notes, as your teacher is going to look for the notes later in the class. So let's look back at the exponent rule that we've learned in the past. Now we've done a lot with multiplying, and we only briefly did a little bit with dividing, so let's review that. If we simplify x to the 6 over x to the third, x to the 6 represents x times x times x times x times x times x, and x to the third is x 3 times. And with multiplication, if there's something on the top and on the bottom that's the same, we're able to cancel them out. And so for each x I have on top and the bottom, they're going to cancel out, and what I'm left with is our 3 x's, which is x to the third. And we've already discussed this rule, but just to kind of look at that, we're going to look at that relationship, that pattern told us the quotient rule, in which if we had the same base, such as a to the b over a to the c, we can take the two exponents and subtract them. But let's take a look at an example here. If I have something like b to the 6th over b to the 10th, and I were to apply that rule, and I would go ahead and subtract 6 minus 10, the problem here is I get b to the negative 4th. Now, negative exponents are not accepted answers in math. So, there's something that we're going to learn to deal with a negative exponent. To divide we always divide the coefficients and subtract the exponents. However, if you end with a negative exponent, it must go to the opposite side of the fraction bar and make it a positive exponent. So if it's on the top as a negative or on the bottom as a negative, we're going to flip it to the other side. Let's take a look at our first example. We're going to simplify this expression here. Now the numbers just get divided. If it's for example, 4 over 2 will divide to just give us 2. The x's, we're going to apply the exponent rule, the quotient rule, in which you subtract the two exponents. And so what we have here, again, 4 divided by 2 is 2, we'll end up with negative 5 minus 2. When you subtract the two exponents, you get a negative 7. Currently, this is in the numerator of a fraction. Now, even though there's not a fraction bar drawn there does exist one right here underneath the 2x. And so what we're going to do is take the x to the negative 7th, we're going to relocate it to the denominator, and we're going to make it now a positive 7. And so as you can see, anytime I have a negative, I'm going to switch it so it becomes a positive by placing it in a different direction, or a different place in our fraction. Here's a second example. Now I have two variables, but that doesn't mean the process is going to change. The first thing I'm going to look at are the numbers in the front, the coefficients. The numbers 12 and 8, they have a GCF of 4. That's the largest common factor between the numbers 12 and 8. And so I'm going to divide the 12 and the 8 by 4. For the two variables, I'm going to apply that same rule, where making sure that I take the exponents of the same variables and subtract them. So this is going to simplify to 3 over 2 when I divide the 4 out from the big numbers. So now with the variables, I'm doing 7 minus 2 because the n has a 7 and a 2. The m, I'm going to do 3 minus 7 because that's the two variables, that's the variable that's in common, and we're going to use those exponents. Now 7 minus 2 gives us a positive 5, but 3 minus 7 gives us a negative 4. If a variable already has a positive exponent, we're not going to change its location, but the m needs to be in a different position. So we're going to take that and put it into the denominator of a fraction. So what I end up with is 3n to the 5th, because it was a positive exponent, stays the same, over 2m to the positive 4. Take a look at one more example. We have a negative 3b to the 8th over 3b to the 5th, a to the negative 2. So for this here, I see that the two 3's are going to end up canceling out because 3 divided by 3 is 1. When I apply the exponent rules to the b, I'm going to do 8 minus 5. Now what you see here is that I don't have to do anything with the a because I don't have a matching variable in the numerator. So I'm just going to hold tight for that for just one moment. So for b, 8 minus 5 gives us a positive 3, so that doesn't have to move location. It's going to stay where it is. But a to the negative 2 is still not an acceptable answer. We cannot have a negative in our final answer for exponents. So what I'm going to do is take it from the denominator, and I'm going to move it up to the numerator. Now, as you can see, I don't have anything left in the denominator, which is why I don't have a fraction anymore. That negative in the very front just carried along in each one of our steps, and so it ended with a negative b to the third, and it's staying in the numerator, and then the a is moving up to become a to the second power. So these are just a couple of examples. What you're going to do now is after you finish taking all these notes on these examples, you're going to go back to our Algebra 1 website for Unit 7. There's a practice number 1 that you're going to do. You're going to attempt all of the problems, complete the activity, and do the work and any kind of work in your notebook. Once you're finished with the entire activity, let your teacher know and get everything checked. If you have done well on it, you're going to go ahead and move on, and we're going to take a quiz. If you have not done well on it, the teacher's going to review things with you, and you're going to attempt a second practice a little bit more straightforward. Please let us know if you have any questions.